Okay, 2024 question number 1. Which of the following represents the electronic configuration of a silver atom? Tick the correct answer. Now, unfortunately, or perhaps embarrassingly, I don't have a paper copy of the periodic table, so we'll have to do without. It should be fairly clear from looking at the periodic table that silver comes immediately after krypton rather than argon. Argon is one row up, so it's definitely not going to be either of those two. Okay, and then silver is the 9th element along in the 4D, so we know it's going to be krypton, and then we would expect it to be 5s2 4d9, but obviously that's what's going to happen there is instead of that you're going to get the full D shell and you're going to get 1 in the S, so that is the correct answer. Which of the following represents the electron configuration of a Cu2+ ion? So we can do the same again. Copper we would expect to be 4s1 3d9, but sorry, we would expect it to be we expect it to be 4s2 3d9. The perils of trying to do this without looking at a periodic table immediately clear, but instead of that it's going to be 4s1 3d10. So that's going to be our copper atom, and then if I take 2 electrons away from that, I'm going to first lose my 4s1 electron, and then that's going to go down to 3d9. So I just want 3d9 by itself, which is going to be that one there. So we have 4d10, 5s1, and 3d9. Okay, 2 easy marks straight off the bat. Calculate the volume of the trophy, assuming that it was solid silver. The density of silver is 10.5 grams per centimetre cubed. Okay, so a super easy density calculation to get us started with one slight unit conversion to soften you up for later in the question, because we're given the mass in kilograms, but we're given the density in grams. So we know that our density is 10.5 grams per centimetre cubed, and our mass is, let's go 4,600 grams, and we want to know the volume. Okay, well, density is mass over volume, so volume is mass over density, which is 4,600 divided by 10.5. So if I do 4,600 divided by 10.5, if you can see that, I get 438, 438, and that's going to be in grams, it's going to be centimetres cubed. Okay, so good idea here to just double check that you're not asked for any specific kind of unit. So it just says calculate the volume, it doesn't say you have to calculate the volume in a specific unit, so that'll be fine for us there. Trophies are made of bronze, which is an alloy, and then we're given this formula where the density depends on the mass of the copper, the mass of the tin, and the volume. And you're asked to calculate the percentage of tin in a sample of bronze with density 7.85 grams per centimetre cubed. So this 7.85 here is this value, and then we know that the mass, the molar mass of copper is going to be 63.55 from our periodic table. The molar mass of tin is 118.71 from the periodic table, and we're asked the percentage of tin, and we're told that Y is the fraction of tin. Okay, so Y is the number that we're trying to find here, and that's going to be a fraction, so it's going to be out of 1 rather than out of 100, but we'll just convert it to a percentage afterwards. So again, this is a very easy question, so we'd expect just 1 mark for doing this, which is what we get. So we're going to do 7, I'm just going to put the numbers in and then see if it's easy to work out, equals 4 times 63.55 plus then the difference multiplied by the fraction, so it's going to be 118.71 minus 63, oops, not 6.3, 63.55, all divided by the volume, which is 5.93 times 10 to the minus 3 multiplied by 6.022 times 10 to the 23. Okay, so then we want to work out y. We don't need to be too laborious about this, so it's going to be 5.93, that's not to the minus 3, to the minus 23. Minus 23 times 6.022 23. You can tell that I grew up with calculators before you could put the whole equation in. Times by 7.85, bring that there, and then divide by 4. Subtract the 63.55, and then divide it by the difference of 118.71 minus 63.55 to give us 0.118, which as a percentage is going to be 11.8%. Okay. E. So now we move on to unit cells. Bronze generally has the same structure as pure copper. Copper has a face-centered cubic unit cell shown on the right. These questions, if you've not done these kinds of questions before, they can be a little bit tricky, but once you realise how they work, they can actually be quite a lot of fun. So the atomic radius of a copper atom R is 128. Calculate the length of the side of the unit cell in centimetres. All right, so unit conversion, picometers to centimetres. We are being asked to find this number here, so this is just Pythagoras. So we have A. This is 4 times 128. All right, so A squared, well, they're both A. So 2A squared equals 4 times 128. I can't do that in my head. 4 times 128. 512 equals 512 squared. So A equals 512 squared, divide by 2, take the square root, I get 362. Okay, now 362 is picometers, because I didn't change from my picometer up here. So I now need to put that into centimeters. Well, I know that a picometer is times 10 to the minus 12 meters, but that's not good because I want it in centimeters. So there are 100 centimeters in a meter, so that's going to be 362 times 10 to the minus 10 centimeters, but we might as well use standard form. This is not standard form because this is not between 0 and 1, so I can shift the decimal place and get 3.62 times 10 to the minus 8 centimeters. Shifting the decimal place in these standard forms always gets me a little bit worried. I usually spend just as long checking it, convincing myself that I'm right. I guess what I've done here is I've divided by 100 here and then times by 100 here, so I haven't made any overall change, so that's fine. I think you wouldn't need to worry too much. As long as your answer is in centimetres, you get the mark for that. Okay, no problem. All right, so we have 3.62 times 10 to the minus 8 centimetres. Usually it is good practice to show all of your working in the space provided, although generally if there's only one mark available, you'll only get the mark if you get the answer right. There's no half marks. All right, if they're going to give you a mark for working, there'll be 2 spaces here, two mark boxes here. All right. Calculate the volume of the unit cell. Well, the volume of the unit cell, very nicely, they've just asked for centimetres cubed, which is going to be very easy because that is just going to be our length of the cell cubed. So I can just do 3.62 times 10 to the power of minus 8 to the power of 3, which is the answer. So they've really given the marks away for this one. 4.74 times 10 to the minus 23 centimetres cubed. And then here we're going to have 2 marks, so I'm working. Calculate the density of the copper metal in grams per centimetre cubed. Okay, fantastic. So we know what the volume of this is. The volume of this here is our 4.74 times 10 to the minus 23 centimetres cubed, okay, which is the same units as what we have here, so no unit conversion required here. All I need to work out then, to work out the density, is the mass. What's the mass of this in here? Alright, well, in order to work out the mass, I just need to know what the mass of one individual copper atom is, which is going to be easy because it's the molar mass divided by Avogadro's constant, which I'll go through again later, multiplied by the number of copper atoms. So, first task is to work out how many copper atoms there are in here. Well, I've got each one of these on the corner. I've only got corner and faces. All right. With other unit cell questions, you might get edge ones, and you might get ones fully enclosed. But here I've only got corner and face. This corner one here, that's only 1/8 of the copper atom. You know, you might want to spend some time convincing yourself that in order to make this one whole copper atom, you need another cell here, another cell in front, another cell in front, and then 4 more on top, or however you want to do it. If you take a sphere, in order to get a corner, you have to cut it in half. So you have to go from 1, you cut it in half, then you cut it in half again, and then you cut it in half again to get 1/8. However you want to think about it, that's fine, but that's 1/8 of a copper atom, and there are 1, 2, 3, 4, 5, 6, 7, 8 corners. So there's 1 from the corner pieces. All right, so corners, 1. Okay, and then faces. So on this face, this copper atom here, that's half of the copper atom. How many faces does the cube have? It has 1, 2, 3 on the side here, 4 at the back, 5. And on the bottom 6. So 6 times a half is 3, which gives me 4 copper atoms in total. So that is where your extra mark comes from. If you can work out the number of copper atoms in the unit cell, they'll give you a mark. All right, and then you get the other mark for working out the density. Okay, so quite simply, all we need to do now is work out the mass of those 4 copper atoms and divide it by the volume. So, the mass of the 4 copper atoms is going to be 4 times 63.55, but that's the gram per mole of copper atoms. I don't have a mole, I just have 4 of them, so I'm going to divide it by 6.022 times 10 to the 23. So that's a calculation that a lot of people struggle with. The molar mass divided by Avogadro's constant gives you the mass of 1 atom, and that's something that if you're not sure about, you should spend some time thinking clearly about, because it's useful to just be able to do that calculation very quickly. So this divided by this gives me the mass of 1 copper atom. I multiply it by 4 for my 4 copper atoms. So if I do that, I'm going to get 4 times 63.55 divided by 6.022. 4.22 times 10 to the minus 22. So that's my mass. So then my density is just that divided by the volume, which I worked out over here, 4.74. 4.74 times 10 to the minus 23. 4.74 times 10 to the minus 23 gives me 8.9. Now, what units have I got? Well, this is my mass in grams, and this is my volume in centimetres, so it's centimetres cubed. At this point, it's always useful to just reflect on your answer briefly. Does 9 grams per centimetre cubed make sense for the density of copper? Well, if I have a centimetre cubed of water, all right, or 1 millilitre of water, that's going to equal 1 gram. So is copper, 9 times heavier than an equivalent amount of water? Yes, it is, right? Or is, what are we working at again? Bronze, yes, it is. Now, this is, I don't expect you to know exactly what these density numbers are, but if you get an answer that's something like 0.1 grams per centimetre cubed for a metal, it's obviously going to be wrong, okay? Or if you get 1,000 grams per centimetre cubed, That's like you're squeezing in a kilogram, right? Like a couple of bags of sugar into the space of 1 milliliter of water. That's going to be wrong as well. So just, generally having a little think about it will tell you whether or not this is a reasonable answer.